All right, we're having a look at the effective annual interest rate, and this can be quite a confusing thing to do if you don't quite get your head around it. Essentially, for compound interest, we've been given a formula, A equals P, 1 plus R to the N. But we know N and R both change because of different compounding periods. Like if these will change depending on whether you're compounding annually, monthly, quarterly, etc. So R and both change. I spelled change wrong. Oh, I'm not an English teacher. Depending on compounding periods. So the concept of effective interest rate is trying to just provide someone with one number so that they don't have to keep repeating their calculations based on compounding at different, given this percent, but it's compounding monthly, or this percent, but it's compounding annually. We're just trying to give them one number to compare so they don't have to keep running all these calculations themselves. So we're going to have a look at two examples. This time, with the first one, we've got $1,000. We're investing it at 6% per annum, but it's compounding twice a year. So if we were trying to figure out the future value, we'd have our 1,000 times 1 plus R. Well, this would be 6%, so 0.06, but we'd end up dividing it by 2. And it'd be raised to the 2 here because it's 2 compounding periods. So we would be ending up multiplying it by 1.03 squared. Now, if we don't actually chuck the 1,000 in our calculator, we just chuck the 1.03 squared in our calculator, we would end up getting 1,000 times, and we'd end up multiplying at 1.0609, which effectively tells us that, yes, we could do it at 6% compounding twice a year, or we could do it as 0.0609, which is 6.09% compounding once a year. And you can run the numbers for this yourself. Compounding twice a year at 6% is the same as compounding it once a year at 6.09%. So we're just trying to tell them how much it would be if we were compounding once a year. But want an effective rate, so it's effectively what you would get, rate compounding once a year. So let's try this again. This time we've got 5.94%. Oh, so the nominal rate is just the 6% that they told us, twice a year. Which gives us an effective rate. It's effectively the same as 6.09% once a year. Okay, let's now have a look at the second example. We've got $1,000. We're investing it at 5.94% per annum, but this time it's compounded monthly. So if we were running the calculations for 1 year, we'd be plussing it, the $1,000 plus times 1 plus. We'd have 0.0594, and we'd be dividing it by 12 because it's happening 12 times a year, which means 0.0594 divided by 12 actually gives us 0.00495, but the 1 plus. So essentially we'd be multiplying it by 1.00495 to the 12, which means we would be multiplying it by 1.061044, and it keeps going. So instead of telling someone we're going to be charging them 5.94% compounding monthly, we may as well just tell them that we're multiplying it by 0.061044 each year. So if we times that by 100 to get it into a percentage, that's like multiplying it by 6.10% each year. So it just gives them a more upfront number to work with. So the nominal rate with this one was 5.94% monthly, which is effectively the same as 6.1044, etc. percent yearly. So if we have a look at both of those questions, we've been asked which has a higher effective rate, 6% compounding half yearly or 5.94% compounding monthly. This is so, if you were giving someone the option between two interest rate options, like you're at a bank and you're offering them between two deals. And the first deal is that you're like, well, we're going to offer you 6% compounding half yearly. The second deal you're like, we're going to offer you 5.94% compounding monthly. Like if you were the person trying to take out those loans, you would have to go back and run the numbers for each of those and try and figure out and compare those answers. But the effective interest rate is just providing them with one number that they compare. So instead of having to go back and run the numbers, and figure it out individually, we can just compare these two answers. So the higher effective interest rate was the 5.94% compounded monthly because it came out as about 6.10% for a year, as opposed to 6.09% for the year. So the 5.94% monthly was higher, which is good if you're a bank, not great if you're a homeowner. So to get a generic formula to use, every time we run these calculations, we've been using A equals P 1 plus R to the N. The interest itself is the final amount minus what you borrowed, yeah? So if we want just an interest rate, I don't care about, what's a better way to say this? I'm going to end up subtracting off what I borrowed. So we just go with how much you would get from investing $1 for 1 year. So here my A is 1 outside of P plus, our new interest to our new number of compounding periods. And then our final interest is obviously A minus P, so it's the 1 outside of 1 plus R to the N minus the $1 that we borrowed. So to figure out the interest that we would get, it's 1 plus R to the N, where R is the interest rate, minus 1 rate per period. N is the number of periods in the 1 year. So if they're ever after an effective interest rate, yes, you could do it with $1,000 and you could find it for how many years. We're only wanting it for 1 year, and you may as well just assume it's $1 so that you have a 1 out the front here and a 1 here instead of 1,000 and 1,000. All up, it's the same diff. That's effective interest.